So we're gonna pull up test 3 and we're gonna go over it, you know, chapter 4, chapter 5, right? And then if you have any questions, you know, I will be ready to answer to them, right? So again, final exam is next week. I think I have put the dates on the final exam on Brightspace as an announcement, okay? So final exam, okay. The only thing about it, again, I repeat, is it's gonna touch every single chapter. That's the only thing about the final exam. Now, topic-wise, if you compare the final exam with the very test we did, topic-wise, it is about the same level, you know? It's not like some harder questions, stuff like that. It is just for you to go back in time and to remember chapter 1, how to factor, chapter 2, rational expressions, chapter 3, radicals, chapter 4, and chapter 5 that were more recent, okay? All right, so we're gonna pull up the test number 3, and we're gonna try to go over it. At the same time, we're gonna come back to, you know, how to write log and exponential function from one way to other way, etc. All right, so let's go back and let's do it. So let me go and test number 3. All right, 421. Test 3 is here. Okay, I'm gonna go and share my screen. All right, so everybody sees this. Is it like the size? Is it good enough for you to see?
Yes.
Do you see the document?
Yes.
You see the document? All right, thank you.
Yeah.
So the first ones we did, I think most of you did them correctly, I think, right? You know, the quadratic equations, that was good. So if in case you have something similar next week, don't forget about it, okay? So the first ones, and something very important, what I said here, solve using what? The square root property, right? And what I said here, in what I did highlight here, somebody can read that to me?
Any other method will not be given any credit.
Right, and yet some people did that, you know. It's like, you know, it's like when the student tells you, no, I don't want no credit. Please give me a 0, okay, on this problem. Because I highlighted any other method will be discarded. And yet some people did the other method, you know. So please try to use the method we said, the square root property. Don't break down the x minus 1 square. Subtract 13, right? You know the steps, subtract 13 from both sides. So you get x minus 1 squared is equal to 5. And then what you do next?
Square both sides.
Square or square root?
Square root, I'm sorry.
Square root both sides like this. And then what we don't forget every time we take the square root of both sides, what we don't forget to put?
With a 5, a plus or a minus.
Exactly. All right, because there is the formula in math, when you say square root of a squared, it gives you 2 outcomes, a or negative a. That is why we have to put plus or minus here. So my next step will be an easy one, which is x minus 1 is equal to plus or minus square root of 5. And then we just add 1 on both sides. And then we're done, right? It says this x is 1 plus or minus square root of 5. Now, in the last test, most of you did that correctly. Most of you, I have to say that, okay? All right, that was a good one. So now the next one, again, same thing. Use completing the square method, okay? Maybe on the final exam, maybe they will just say solve, and then you will have the choice of the method, right? But every time we single out every time we single out a method, you have to follow the method for, if you want to get the credit, you have to follow the method. And you see, this example is a good example for completing the square, right? Can somebody tell me what is the number we need to add on the left side to make it a perfect square?
51.
51? No, no, look, we are doing the completing the square method, right? The negative 51 is good where it is at. You can bring it over to the left side, but it does not help, okay?
Oh,
so
wait.
I'm
So
happy. Yeah, what is the number to add on both sides to make it a perfect square? Is the left side a perfect square?
49.
49, right? Can you tell me what are the two steps we follow to get to 49?
You divide 14 by 2 and then you square.
Thank you very much. You divide 14 by 2, which is 7. You square 7, you get 49, right? So you add 49 to make it a perfect square. So we add 49 here. This is an equation. Everything we did on one side, what do you have to do?
As well.
You have to, exactly. All right, everybody. You see, you do this in your test next week. If you ever see something like that, I already give you credit for that. I already give you credit for putting 49, 49, right? And what you get? We get x. This becomes a perfect square, right? That was the whole purpose. Which square is that? What you have inside the square?
X plus 7.
Exactly, thank you. 7 being the half of 14. If this was minus, what would be?
X minus 7.
Exactly, it would be x minus 7 if this was a minus. So now, you see, now we get something that looks like the problem number 1, right? You see, after adding 49, we get something that does look like problem number 1, okay? So now we have to do is just to x plus 7, we take square roots plus or minus square of negative 2, right? Which we don't leave like that. We say plus or minus I square root of 2, right? We get x equal to negative 7 plus or minus I square root of 2. That is completing the square method. Okay. Okay, the next one here, use the quadratic formula. In order to use the quadratic formula, before we say what is A, what is B, what is C, what do we need to have on one side?
0.
We need to have 0 on one side, right? I don't know on the final exam how your equation will be given. Maybe on the final exam, maybe your equation will be given 3x squared plus 4x equal 2, right? If that was the case, what you gonna do? If the equation was given like that, what you gonna do before you apply the formula?
You have to
0.
over.
You have to make it 0 by what? By subtracting 2, right? Okay, on both sides. So you get 0 on one side. But here, this is, in this equation, we already have 0 on one side, which is good. We say A equal 3. Now, all of you memorize the quadratic formula?
Yeah.
Everybody? All right, so somebody who memorizes it, can you tell me what's going to be the quadratic formula here? What's going to do?
It's going to be negative 4 plus or minus the square root of 4 squared minus 4 times 3 times negative 2 all over 2 times 3.
Yeah, that's good. Good. So you know the quadratic formula. So if you have more math classes, you have to hold on to them until you are done. Okay. If you know quadratic formula, and then you have your next class is, I don't know, maybe like 163. If your next class definitely is 163, then you need to know the quadratic formula.
Is that pre-calc?
Yeah, pre-calc. If your next class is 153, which is statistics, you will do less of that, okay? When you do statistics, you will do less of, you are smiling, Lawyer, right?
What?
So you wanna part ways with the algebra stuff, right? I mean, algebra is, I like algebra better than statistics.
Yeah.
I do personally. So, but statistics, when you do statistics, you will deal less with the quadratic formula, at least, you know, the beginning of statistics, right?
Yeah.
You see, all the disciplines, they meet up where? They meet up in the advanced levels. When somebody is in advanced statistics, they do, you know, a lot of calculus stuff. Okay, when they are in advanced statistics. All right, so right here. So now here, if you write this, you're almost done. You have just to watch out the mistakes. You know, you use a calculator, so you watch out the mistake to capitalize, get all the points. This is 16. The two minuses combine to plus 24, right? You see, it's going to be -4 plus or minus square root of 40 all over 6. Now, if nothing tells me to simplify, I can stop right here. If nothing tells me to simplify. But if I want to simplify, I can go ahead and do it. You know, you have just rewrite, okay? So 40 happens to be 4 times 10, right? So 40 is 4 and 10. So 4 comes out, it becomes a 2. If -4 plus or minus 2 root of 10 all over 6. Now I can divide everybody by 2. This one is 3 left. This one goes, this one 2 left. It's going to be -2 plus or minus root 10 divided by 3. Again, you are not compelled to go from here to here, you know, especially if you are not sure, right? So we avoid to make something right become wrong. All right, so now comes this. All right, y equal to x squared minus 4x minus 5. Okay, so of the 3 points, of the 3 cases A, B, and C, who is the easiest to find?
The y.
The y-intercept, right? Remember, the y-intercept is when x is set to 0, right? See, the y-intercept is always set x to 0. If we set x equal to 0, everybody goes until negative, except -5, right? So y-intercept is -5, or as a point is 0, -5, right? So when I put my point right here is 0, this is y-intercept. Okay, and then comes the vertex. Now, a vertex is a point that has an x coordinate and that has a y coordinate, right? That is a vertex. It has an x coordinate, it has a y coordinate. So now, how to get the x coordinate of the vertex? How to get the first number of the vertex? What you do?
-b over 2a.
Negative b over 2a. Everybody remember that? Negative b over 2a, right? That is the x coordinate of the vertex. Negative b over 2a. B is -4. It's going to be -4 over 2 times 1, which is 2. You see, that 2 is the one we put here. That is the x coordinate of the vertex. What is the y coordinate of the vertex? What you do next?
Plug in 2.
Exactly. You plug in 2 into the equation, we get 2 squared minus 4 times 2 minus 5, which is -9, that we put here. So my graph was a little bit short. I apologize for that, right? 7, 8, 9, that is 2, -9 right here. Okay. Now for the x-intercept now, what variable now is set to 0? For the x-intercept, what variable is set to 0 now?
The y.
Right.
The y, exactly. when you set y to 0, it means I have to solve the equation x squared minus 4x minus 5 equal to 0, right? Now I go through my toolbox of solutions, how to solve this. In my toolbox, I have quadratic formula, I have factoring, I have completing the square, I have squares property. But for this particular equation, what method goes faster? What method will go faster for this particular one?
Factoring.
Factoring. This one is a nice one, right? So we factor. And do you remember how to factor this one? What are the two factors?
-5 and 1.
-5 and +1. I agree with you. So x minus 5, x plus 1. So we get x minus 5 equals 0, which is x equals 5. X plus 1 equals 0, which is x equals -1. So what are my two x-intercept? 5, 0 and -1, 0. Everybody understands this? For the x-intercept and for the y-intercept for the vertex, everybody understands these three cases? All of you? If you have some doubts, you ask questions, okay? All right, so now my two x-intercept are -1, 0 and 5, 0. So that's going to be my graph like this. All right, that is my graph. And if you want to test you in this topic, in the final exam, if you want to test you, pretty much it's going to be the same questions, right? Pretty much. What is a vertex? What is x-intercept? Well, no, what are the x-intercept if they exist? What is y-intercept? All right. So now this application problem where something is launched upward, etc. By now we become tired of this problem because we have seen this too much, right? We have seen this problem too often. So, but here now the h is the height, right? The variable h here represents the height after t seconds. And the t represents the time, right? Okay. When the object will it reach the maximum height? Every time there is a keyword that tells me this is about the vertex. The answer is about the vertex. What is that keyword?
When?
Maximum?
Maximum.
Oh.
I'm talking here, this is a context of a quadratic, of a parabola, right? This is a context of parabola, and I see the word maximum. Maximum or minimum, when you see them, you know your answer is about the vertex. Now, the challenge for you is what part of the vertex will be my answer? Is it the x coordinate of the vertex or is it the y coordinate of the vertex? That's going to be a challenge. Now, look, the first vertex we have found, 2, -9, right? 2, -9. That's the vertex we found here. When I tell you, what is the minimum here? What you tell me? Is it the 2 or the -9? What is the minimum? What's your answer?
Whatever's the y.
Exactly, which is a -9. Thank you. What is whatever is the y. Now, when I say when the minimum here in this case of the parabola here, when the minimum was reached, when? Well, the answer will be when x is equal to 2, right? Same thing here. When you say when the object will reach the maximum, we're talking about the h of the vertex, the first number of the vertex, the first coordinate. And that is -b/2a, that's it, which is -160 divided by 2 times negative 16, which is 5, which is 160 over 32, which is 5. When? 5 seconds, right? The maximum will be reached after 5 seconds. All right. What is the maximum height? Now what you do now? Now the answer now is the second number of the vertex, right? When you say what is the maximum height? And you know how to find the second number of the vertex. What you gonna do?
Plug it in.
Yes, plug it in, that's it, right? So you plug in that number 5 right here. We plug in here, so we get negative 16 times 5 squared plus 160 times 5, 1200, right? This is negative 16, until we do the math, okay? I think it is like 1600 feet. All right. So this is an example of application. So now for the word problems you likely will expect in the test. What are they? This type of word problem, the one where we ask when it does hit the ground, right? Sharing the job, right? You know, the equation, you remember the equation when we share the job, everybody remember that equation? You remember that equation, right?
Yes.
Yes.
When I say I can do my job in 7 hours, and you can do the same job in 5 hours, right? How long is it going to take both of us if we work together? What equation you get? 7 hours, 5 hours. What's going to be your equation? Can somebody tell me?
I will tell you.
Go ahead.
It would be 1/5 plus 1/7 equals 1 over x.
Exactly. You see? And if you remember that equation, you write that equation on your paper, you already get partial credit for that, and then you have to solve it. Okay? It's half and half. All right. And then the variations, you know, varies directly where y equal kx, varies inversely y equal k over x, etc. Okay, now everybody got this to write, you know, the first one, this is not a function because it fails the vertical line test. This is a function because it passes the vertical line test, right? Okay, now comes this. As much as I said, I don't know how many times I said in classroom, the parentheses are not multiplications. Still, some people treated them as multiplications. You see, these parentheses right here, not a multiplication. Okay, these right here, not a multiplication. Right, and you know, a lot of people lost good amount of points because of that. Not a multiplication. Rather, what it says, don't overthink this stuff, don't overdo it. It just tells you this is actually f of 2 plus g of 2, that's it. Okay, this is the question B is f of -1 minus g of -1, that's it. All right, which means in the question A, you're going to plug in 2 in F, you're going to plug in 2 in G, and then you add up the numbers. In the question B, you're going to plug in -1 in F, plug in -1 in G, and then you add up the numbers, right? I mean, you subtract the numbers. Everybody see that? So please don't overdo it. Don't do something. It's not a multiplication. It's not a multiplication at all. And I think in the past test, a lot of people actually lost a lot of points in here. I wasn't expecting that, you see. So try to avoid that come to final exam. So you have to say, for example, the first one says 2 squared. You see, I'm doing this one. It's 2 squared plus 6 times 2 minus 15, right? That's the first one. And then I'm doing this one right here. You see, is -4 times 2 plus 1. And then what I do in between, I add them up because it says plus right here. That's it. So this is -1. This is 4 plus 12 minus 15, which is -1, plus -7, which is -6. I mean, no, this is 1 right here. Is 1 plus -7 is -6, right? The next one right here, I do f of -1, which is right here, which is -1 squared plus 6 times -1 minus 15, that is f of -1. And then I do g of -1, which is -4 times -1 plus 1, right? And then I minus them. I minus here. So this is 1 minus 6 minus 15, right? 1 minus 6 minus 15, which is -20, minus, and here this is 4 minus 5, which is -25. Okay, so if I had replaced, you see the same stuff right here. If I had replaced the minus with a product, if I have said fg of -1, what we would do? Can somebody tell me? The same functions. If I ask you what is fg of -1, what you do?
Multiply f and g.
Exactly. You multiply the two numbers you got, you just multiply them, right?
And
It's going
plug
to be
in.
-20 multiplied by -5. I mean, by 5, right? You see, fg of -1, since we already have done the work, we already did f of -1 and g of -1, it's going to be -20 times 5, which is -100. Okay? So please remember that the parentheses in this case, they don't mean no multiplication. It is off. This is a variation. You evaluate at 2. You evaluate at -1. You are not multiplying by 2. You are not multiplying by -1. Okay? This one here, the next one here is about the same thing. We are not multiplying by x. Rather, we are simply saying this is f of x plus g of x. That's it. F of x as you see it, right? Plus g of x as you see it. Everybody see that? Now, how much is f of x?
10x squared plus 17 minus
Plus
9.
minus 9, right? And then we add that, we add what? We add g of x, which is?
Negative 8x squared minus 5x plus 12.
Plus 12, right? And then we add them up. If you have any like terms, we group them. Okay? If you have any like terms, we group them and then we get the answer. All right? So, for instance, 10x squared plus -8x squared is 2x squared. 17x minus 15x is 2x. -9 plus 12 is 3. Right? Okay?
I can't believe I got all 3 of those wrong. I'm so mad at myself.
Yeah, I mean, you see, Noel, and when I was grading, all the people who pretty much did exactly the same thing, you know, it's like how many points lost? It's like 16 points lost or something like that, right?
Oh, geez.
So, because you know, not 1, not 2, not 3, but a good amount of students took that as a multiplication stuff. You see, and that is overdoing something. That is overdoing the question. Sometimes, the questions are way simpler than that. Okay. So please, in the next week, when you see f plus g of something, the number in front is not multiplication. It is evaluation. You are evaluating at this. You are evaluating at this, right? So, all right. So next question right here, I think, okay, this one, I think, except few people, majority of students did that right. Majority of you did that right. The domain, you see, the domain is all the x values. What are they? 0, -1, 1, 2, 4, right? I even don't need to reorder them. I don't need to. Now, what is missing? Like some people didn't do, I did not penalize that, right? But if you were a math major, I would. But it's not a math major, so we kind of say, okay, what is missing around the domain?
The bracket?
How
Or
do you call them? The
Parentheses?
the braces.
braces.
Yeah, the braces. That was missing. Some people did not do them, or some people put parentheses. If you put parentheses, is wrong. It's not is rigorously wrong. If you put brackets, is rigorously wrong. So the correct way to enumerate a set, if you want a set of numbers, if you want to enumerate them, the correct way is to put between braces, right? But I did not hold that against anybody. The range now is a set of the y values, 5, 2. I don't need to repeat the 2 twice. I got 0 and 1, right? Okay, almost everybody got that right. So now comes the exponential equations, right? Exponential equations. I think we talked about it last time, but we're going to repeat that. You see, so for you in Math 083, the only exponential equations we're going to ask you, they will be exponential equations where you can manage to have the same base. Where you can manage to have the same base in 083. These will be the only questions we're going to ask you in this topic. If you go to the next class, they can ask you some other exponential equations. But for your 083 class, it's going to be about only these, right? Which means when you see 27, it is intentional, right? We didn't put any number right there. We put 27. We're going to put numbers that you can write in base 3, right? And 27 happens to be 3 to what power? 3 to the third, right? Okay. So we're going to say 8x minus 5 is equal to 3. After we write everybody in the same base, now you can equate the exponents. So you get x equal 1, right? So same thing here. You see, from the get-go, I don't say 9x plus 3 equal 3. I don't say that. Because 5 and 25 is not the same base, but 25 happens to be 5 squared, right? And this is exponent 3. This, when you compound the two exponents like that, what we do to them? Do we add them up? Do we multiply them?
Multiply.
We multiply them. So we get 5 to the 6th power, right? Now that I have base 5, now what equation I get now? I do 9x plus 3 is equal to what?
6.
6. 9x plus 3 is equal to 6. And then I solve. I get x equal to 3 over 9, which is 1 over 3, right? Okay. Now comes this. Okay, let me take like a couple of minutes since we have time. Talk about what is a log, really. You see, in mathematics, there's a lot of way to introduce log in math. I remember when I was, the first time I encountered log, the teacher introduced log another way, which was more, I was a math major, so the introduction of that log was more complicated, okay? But for us in 083, the simplest way to introduce log is to say it is another way to write exponential expressions. Another way to write exponent. That is the simplest way to introduce log, you guys. Is another way to write just like, you know, we found another way to write square, right? When you say 4 squared is 16, in math, we introduce something that's called square root that tells you square root. Okay, now, in the order of things, what do you think in math? Which one do you think in math came first? The square or the square root? Even if you don't know exactly. What we think, you know, is like between the egg and the how you call the chicken, right? What's come first, right? In the order of things, I think, right? I'm not being here rigorous here. I don't know, I have to, but I think even the way we learn it at school, the squaring came first, right? We knew we knew squaring because we knew multiplications, right? When you multiply a number by itself, you get square, right? And then we introduced something that's called square root. That is the reverse process of that, right? You see, you get 5 squared is 25, right? And then you introduce a reverse process of that, which is square root of 25 is 5. That is very needed in math. In math, it's very needed to go one way and to know how to go the other way around. Okay? The reverse process, the inverse thing, the inverse process. It's like, you know, what addition is to the subtraction, right? It's like what multiplication is to the division, right? It's like what square is a square root, what cube is a cube root, etc. So that is the same way, that is the same relationship between exponential and log. You see, we say exponential base is, this is a base of x is equal y, right? This is exponent. We want to invent the reverse process of that. And believe me, in math, that is very important. It's very, very important in math to know what is the reverse process, what is the inverse process. You see here, I'm not talking about the inverse of a function because we don't do that in OAT3. But log is the inverse function of exponential, right? So when you look at this, what was the input? The input is the x, right? We put x into the base A, we get y. Y is the output. Now we said there is another operation that we call log with the same base, right? Logarithm function, but we say just log to make it short. Log the base A. So basically, what is another way to write that? What was an input here will be an output. What was output will be input of y is equal to x. So I remember this x was the exponent, right? Log, I guess here's log is another way to express your exponent, right? Look now, look at what is the advantage of the log. This exponent here was inside an expression. The x is not by itself, right? What log allows you to get? What log allows you to get it to get the x by itself, right? That is huge. That is very important. Okay? Log allows you to get the x by itself. That is the definition of log. Look, here we're talking about the definition of log, right? Okay? So that is the definition of log. What is a log? Is another way to express the exponent. Okay? And that is the simplest way to introduce log to somebody who never saw log before. Okay? To say log is another way to express the exponent. Now, when we learn the definition now, okay, now we're going to say this. Look at this one. What is the base? So the 9 is the base, right? What is the exponent?
3.
It's 3. So what is the log form of this? I'm going to find log. I have 3 cases to fill. I have 3 squares to fill up, right?
9.
That is a log. That's the definition of a log. the bottom square right here, we're gonna put what? Always gonna put the base, right? So basically here, the bottom square here, way at the bottom, you know, at the end of the G, that is the base here. And here by itself, this is the exponent. Okay? So in my expression, in my exponential expression now, the base was 9, right? Gonna be log base 9, and the exponent is 3. I put 3 here. So what's gonna be here then? 729, right? So log base 9 of 729, log is a function that is the inverse process of the exponential, right? Which is 3. You see, if I do this now, look, if I do this, 10 to negative 3, negative 3 is equal to 0.001, right? Okay, tell me, who's going to tell me what is the log form of this?
I can.
Okay, what is the log form of this? Go ahead, Natalie.
Log 10,
Where I'm going to put the 10?
log base 10
Guys, right here, right? Of what?
of 0.001
Equal to?
negative 3.
The exponent is always by itself here on this side, always. I say 0.001. Okay. And look, log base 10 actually is in your calculators. So log base 10 actually is the function which is programmed in your calculators. Let me show you mine. Let me show you my calculator. Log base 10 is programmed in all scientific calculators. Not all the logs are programmed. Not all the logs. You see that log you see here? You see that log right here? It's log base 10. Okay, it's not log base 2. It's not log base 3. It's not log base 5. It's log base 10, right? You see, when I do 0.001, I put log of this, what are you going to find? Negative 3. You see that? Okay. Log base 10 is programmed in your calculator. Okay.
I have a question about log as well.
Yes.
So this is on my open math. I had to Google this. This might have been in our textbook. I don't know. But it was a log without a base. And I had to search up, like, what do I do when the log doesn't have a base?
Yes, that's base 10.
Yeah.
Okay, so look, thank you very much. That's base 10. The textbook does not go to that extent. My open math, I guess my open math goes there, but the textbook does not. And you know, that's why I didn't go there, you know, to avoid confusion. We try to follow the textbook. We have two particular logs. We have two particular logs. The log base 10, which is programmed in your calculator right here, this log right here. Every time you see the base is missing, it's not because we forgot about it. It's because it is log base 10. Okay? When the base is missing, it is base 10. And there is another log, which is log ln, log base E. And E is this number right here. Look, this is E. E is this number right here. You see this number right here? That's called E in math. 2.718. You know, in math, in science, we have some numbers, you know, that are known. For instance, pi is 3.14, etc., etc. You have E, you know, pi is right here, right? Pi, you see 314, etc. You have the number E, you know, etc., etc. Okay, so those numbers are known, but in OA3, you know, when I look at the textbook, I didn't see no E, I didn't see no log based, what we call the common log. I just stopped. I just said log in general. Okay. So, but if you do my open math and you see the log, the base is missing, is base 10. Is base 10, right? All right, thank you very much for that. Okay, so now that we learned the log a little bit, so now how I'm going to write the number 13, how I'm going to write the exponential form now. The exponential is the other way around, is I have 3 boxes to fill up. I have the box of the base, I have the box of the exponent, I have the other number, the outcome, right? What is the base here? Clearly, what is the base? Without doubt.
3.
The base is 3. What is the exponent without doubt?
-4.
Exactly, always a number by itself. This one is always exponent. Equal to what? 1 over 81, right? So when I say, you look right here, just to elaborate on this log stuff. When I say, okay, let me try to find log base 2 of 16, if I can find it. You see, how you understand log, Noel? You understand log by saying, if somebody asks you what is log base 2 of 16, they're asking what? They are asking you an exponent. What exponent of 2 will give you 16? If that exponent is easy to figure out. Sometimes it's easy, sometimes it's not. When it is easy, we can do the mental math. We try to come out with an exponent. When it is not easy, then we have to use a calculator, right? But look at the two numbers. What exponent here? This is what log. When somebody asks you these questions, they're asking you, what is the exponent of 2 that will give you 16?
4.
Is 4, exactly. That's 4. Okay. This is the best way to understand log. Log is actually an exponent. Now, when we say log base 2 of 10, right? Can we figure out exactly that number? Mentally, can we figure out that number mentally?
No.
No, right? Because if you go over the exponent of 2, we have 2 to the 1 power is 2, 2 squared is 4, 2 cubed is 8, 2 fourths is 16, right? You see? I never get 10, right? So it's going to be, that number will be a number between 3 and 10, 3 and 4, right? But it is very hard to know. You have to use a calculator for that. Okay. All right. I think, fairly we can say that we did review for the final exam. Now the official final exam, you have like some 100 problems. You have about a week. You can dive into it. You also can redo the tests we did, et cetera, et cetera. The tests and quizzes we did, you can redo them. And then what is good about the review, you have, that was posted, you have some step-by-step solution key, right, on Brightspace. That also helps. My advice for you for the final exam is not to panic, but at the same time, know that it is 30%, right? The percentage is a little bit high, okay, for the right? And not to panic, but it's going to be just a test. When I say it's going to be just a test, I mean by that the questions will be the same level of questions that we saw in each test, same level. It will not be a harder test because it's called the final exam. It will not, okay? All right, so somebody has any questions? I said the final exam date is December the 14th, which is Tuesday, 11 to 1. It's not 11:10, it's 11 o'clock on Teams, right? Of course, it's going to be the same stuff as a test. Connection, you're going to connect on Teams. You're going to maintain the connections the whole time, your camera on the whole time until you are ready to take pictures. 2 hours, 20 questions. I think the time is enough. When I say 2 hours, and 20 questions, it is enough time to do it. I think so. More than enough, actually. All right. Do you have any questions?
How much is that? Like 10 minutes per question?
Yeah, more than enough. From my experience, some people get done even in the first hour. Because some questions, they go fast if you know them, actually. If you do know them, they go fast, right? Some questions, they just go fast if you do know them. How to factor. You see, factoring, if you know how to factor, it goes fast, right? How to log, if you have exponential form and you want to write log form, If you know how to do it, it goes very fast. It takes like a couple of seconds to do it. All
So
right.
this is our last class.
Yeah, that's our last class. So the next time you're gonna meet, it's gonna be Tuesday, right? And it was a fun class, I have to admit. It was a good class, right? So I wish everybody, you know, good luck for the final exam. And you know, the grades you're gonna have is, you know, the 3 tests, 3 quizzes, my open math, right? You know, and then the final exam. So if I have time, now I have a lot of grading to do now. But if I have time, I could calculate your actual grade, right? If I have time. But if somebody wants to know the actual grade individually, if you email me, I can take a look and then answer to you, okay?
What
Before
do
the
you
final
mean
exam.
before
Before the final exam, yeah. You know, out of 70%, how much you got out of 70%?
Mm,
If you are interested. If I,
I am interested.
yeah, I would do that for the whole class. It's just like I have a lot of grading to do. I mean, I have 5 classes. I have a lot of grading to do right now. So I'm not sure if I have, but if somebody individually write me an email, right? What is my actual class? How much I'm doing right now? I can do those. It's like a quick calculation. I could do that, you know, I could write on Brightspace what you do, you know, what are the arithmetic steps to get your grade, you know. But if you email me, I will answer to that. Okay. All right, everybody. See you next week.
Thank
Bye,
you.
everybody.
Thank you.
Thank you very much.
Thanks.
Buddy.
All right. Bye.
Thanks, you
Thank you.
too.